last one we figured out what the resulting force was on this box of these two vectors u and v that were given here. And right now I'm figuring out what angle it is. It turns out that the resultant vector, if you have 90 pounds pulling up at 60 degrees, 30 pounds pulling this way, this vector, which we drew, but it's not really that greatly accurate to be drawing these things at this point. Because these, unless you have a computer that's drawing them or you have really great graph paper and you're very careful, these drawings are only approximate. But this, the magnitude of this is 108.17. So notice also this, even though I did the adding and it wasn't going to be that accurate, notice that this angle should be less. It should split these two. Let's make sure that happens. So we were going to figure out what is theta r. Theta r is the angle that the vector r is lying at, and it's going to be at arctan y divided by x. 45 square root of 3 divided by 75. Okay, so I punched this in my calculator, and or did I punch this in my calculator? No, I didn't. And I want to, because I want to show you that this angle came out correct in the sense that at least it should be less than 60 and greater than 0. This is just from the drawing. And it's very important to check your calculations in some kind of thoughtful way. Divided by 75, arctangent. It's 46 degrees. So theta r is 46.102. I'm just going to call it 0.10 degrees. Okay, so that's it. Now, one of the coolest things in the world, you would not believe how freaky it is, but the fact that you can take two forces and put it on a box, and that you can just add the resultant forces is a really amazing thing. I know it doesn't seem like it. It seems like it's probably obvious, but this is a huge, huge thing. And those of you who go on to higher mathematics and physics, you're going to see what a dramatic result this has, especially when you get to quantum mechanics. It's truly mind-blowing. Okay, so we have another problem that is still more or less from the last section, but it's a physics problem, and you definitely want to pay attention to this. I guarantee you, when you get into your first calculus-based physics class, Physics 1, you're going to have a problem just like this. Actually, this will be too easy to give you. They'll start off with something like this. You'll never see this on a test because it'll just be too easy. But I think I can explain some things about it that will be helpful to you. Okay, an object weighing 50 pounds lies on an inclined plane that makes a 40-degree angle with the horizontal. Find the components of the weight parallel and perpendicular to the plane of inclination. So first thing and always, we got to draw a picture. Okay, so here we go. We have 40 degrees. I'll say that's about this, 40 degrees. Here is our box. Okay, trying to make a good-looking box here. Nice lid. And the reason we are shooting this for the second time, and I'll tell you the truth, this is so important for you to get that I wanted to make sure the drawing was really clear. Okay, so here's the deal. Here's what we know. This box weighs 50 pounds. That means that if I have it here and I'm standing on a scale, it's 50 pounds straight to the center of the earth. I'm going to call this the center of mass, and so here is 50 pounds. Notice that this is actually a vector. This is, if this is the xy axis, this vector would be like this. It would be minus 50 lbsj, right? But we're not really doing that. We don't really need that for now, but obviously gravity's going down. What they want us to do is they want us to figure out what are the perpendicular and horizontal components of this with relation to this. It's actually not that hard. So here's what we're going to do. We're going to draw this picture. Here is the perpendicular component of this vector, which we're going to call P, or perp. And here is the horizontal component of this vector with respect to this angle. And this red's no good, I need a better one. Okay, so this, and we'll call this horizontal, which is hori, which is perfectly fine. So how do we do this? Well, okay, so first off, all we really need to do is figure out this angle here, and I'm going to take this out so you can see it. I'm going to show you that this angle is 40 degrees, just like this, and this is so important. When you get into physics, if you can grok this, anyone catch that, grok? You are so going to be happy. This will, on day one of physics, calculus-based physics, they are going to show you how to do this, and they're going to expect you to know how to do it by day 2. So this will be good. How do I know that this is 40 degrees? Well, let's take a look at this. So if this is 40 degrees, here's the line perpendicular, and I'm going to make it as straight as I can. And here's the line that is just falling straight down. So this is more or less like this picture. Let's see what we got. This is 90 degrees. 40, this must be 50 degrees. Similarly, this, get my head out of the way, this triangle right here is 90 degrees. If I look at this triangle, that means that this must be 40 degrees, which is exactly where we are. Now you notice it didn't go straight down to the ground here because I didn't need it to. I chopped it off early because I wanted a right angle here so I could use my sines and cosines. And you'll notice this is our right triangle right here. So now I need to know what is the perpendicular force, and we're talking about the scalar, the magnitude of it, and what's the horizontal force. You'll notice we really aren't even dealing with our i's and j's right now. We're just looking at this picture. Well, so the cosine of 40 degrees from this picture is going to be perp, the perpendicular, P-E-R-P, divided by the norm, which is 50. So the component in this direction, which we're calling perp, is 50 LPS times the cosine of 40. And so this is, we'll call it P for short. Similarly, if we look at the horizontal component, the sine of 40 degrees is equal to this, the horizontal, which I guess I'll just call hori, and divide that by 50 pounds. So clearly, the horizontal component is 50 pounds times the sine of this angle, which is 40 degrees, and we'll call this H for short. I punched it up on the calculator. It turns out that this bit right here going this way is 32.1 pounds. And this bit going this way, it was like 38 and some change. I think it was, yeah, 38.3. Yeah, 38.3. And I usually estimate to the 100th place. I don't know why I didn't here. It doesn't really matter. Watch this problem enough times so you can really do this. When you get to physics, this is going to be huge for you if you can do this. Okay, so now I'm going to really get on to dot products. So I suppose these 2 lectures belonged in the last section, but we'll just put them under dot products. Come back. It's going to be very exciting.